Hi everyone, this lesson is for Algebra 2 honor students. This is chapter 7 and 8. 7.8, adding and subtracting rational expressions and also partial fractions. So let's get started. Our learning targets are basically just adding and subtracting, reverse the process, and then also find partial fractions. So we're just going to start off with a little radical review. And with our radical review, just a couple of things to remember. When you are multiplying radicals, you keep the radical and you multiply the numbers inside. Also, if there's a number outside, so for example, if there's a 3 outside or a 1 outside, right? The numbers get multiplied with numbers, and then roots get multiplied with roots. Same thing with roots that you're dividing. If this was the square root, if this is the square root of a, let's say 3 root a, 6 root b, the numbers can be reduced. Not a problem, but you can't reduce, let's say that's root 6. You can't reduce this 3 with that root. Only roots can be divided by roots. Numbers can be divided by numbers. So when you're simplifying 8 times root 3, two options that you have. Number one, you can multiply them together and you're going to get the square root of 24. Your other option is to, and then you have to reduce that, of course, and then that can break down again to root 8 times root 3. But realistically, what your objective is when you're working with roots is to try to find a perfect square. So, for example, I would try the square root of 4 times the square root of 6 instead, because that would give me 2 root 6, and then that would be my answer. Just a note, when you're working with this, there's so many different ways to get to the same answer, right? And you could have also from the very beginning here, root 8 times root 3, you could have said, well, root 8 is root 2 times root 4, and then you have times root 3, where root 4 is 2, and then you have root 2 times root 3. Remember, roots can be multiplied together, and so that's going to be root 6. So I'm going to get, of course, I'm going to get the same answer, but it's just a matter of, which way you want to actually do this. So for example, root 8 times root 75. There's no real reason to multiply 8 times 75 and then reduce it again when it's already semi-reduced. So I would take 8 and break that down to root 4 times root 2. I would take 75 down and I would multiply that by root 25 times 5. And then find the square roots there. Root 4 is 2. Root 25 is 5. So the 5 times 2 is 10. So these two are done. Then I have root 2 times root 5, which is root 10. So realistically, I have 10 and then root 10. And so that's my answer. For this problem here on the left, this different than multiplying, of course. Adding roots, they have to have the same value, like x's. You can't add x plus x squared. I mean, of course, you can factor something out of that, but you can't add. You're going to take, you would have to have the same exact roots in order for that to happen. So for example, I'm going to take root 12 and I'm going to break that down. So I've got 2 root 4 times root 3. Well, root 4 is 2. So that 2 is going to come out to the front. So now I have 4 times root 3. Now I can actually add that to 9 root 3 because my roots are the same. So 9 plus 4 is 13. So my answer is going to be 13 root 3. All right. Additionally, I have the square root of 40 times the square root of 8, or divided by the square root of 8. So what happens with this problem here is that roots can be divided by roots only, right? Roots can be multiplied by roots, and roots can be divided by roots. So for example, root 8 goes into 40. So this would actually become 1, and this would become 5. And so your answer to this problem is 5. If I had, root 5, thank you. If I had, let's say, the square root of 15 over the square root of 3, same thing. I would also get the square root of 5. But if I had, let's say, the square root of 48 divided by the square root of 6, well, I guess that would be the same thing. I'm trying to find something that doesn't go in there evenly. Let's just say 5. You're not going to leave the root on the denominator ever, okay? You're going to want to rationalize the root, basically getting rid of the root. So you're going to multiply by whatever is on the denominator, whatever root is on the denominator. If it's not factorable, you're going to multiply by that over itself, because with expressions, you can multiply by 1, like I'm doing here, in any form, but you just can't change the question. So you're not going to all of a sudden add an equal sign. You might add like an arrow saying, okay, now I have this, right? Root 5 times root 5 is the square root of 25, but the square root of 25, of course, is 5. And then on the numerator, you're just going to multiply root 48 times 5. But I would actually take root 48 and break that down to root 16 times root 3. Square root of 16 is 4, so that's 4 root 3. So what I really have here is 4 root 3 times root 5, which becomes 4. And then see this 1 in front of the root 5? That gets multiplied by the 4. So you have 4 root 15. And that's your answer, because unlike this case where they're both roots and you can divide a root by a root, root 15 isn't going to cancel with 5 because one's a root and one's a number, not both roots. You can only cancel a root with another root. More simplifying fractions. I would pause the video right now, and then you would come back as soon as you're done, right? So I'm going to work these through, and then you guys would do this on your own, okay? All right, see you in a minute. So the square root of 48 is going to be, again, root 16. Try to think of perfect squares times root 3. And then root 12 is the square root of 4 times root 3. So I've got 4 root 3 times root 4 is 2. So 2 root 3. And I'm not adding these. Oh, yes, I am adding these. I was going to multiply them. 4 root 3 plus 2 root 3 is going to be 6 root 3. And then we're done. For this problem here, I would try to figure out what value goes into both. Like, for example, this is root 7 times root 9, okay? And on the denominator, it looks like I have root 7 times root 4. And so roots, again, get canceled with roots. So I can cancel root 7 with itself. That makes 1. Root 9 is 3. Root 4 is 2. My answer is 3 over 2. But there's so many different ways to get this. You may have done this a different way entirely. For this problem here, I am multiplying. Root 18 is going to be root 9 times root 2, which is 3 root 2. Root 28 is going to be root 7 times root 4, which becomes 2, which is the 4, root 7. And then I'm multiplying these. So remember, numbers get multiplied with numbers. So 2 gets multiplied by 3, so that's 6, and then root 14. For this problem here, this one has, see the root on the denominator, see this 3? Okay, so I'm not adding an equal sign, right? Try not to do that. So this 3 is actually over 1, even though it doesn't look like that. And it's actually going to be root 2 over the square root of 5. Again, we're going to try to get rid of this root 5 on the denominator. So I'm going to multiply by root 5 over root 5. And that's going to become 3 root 10 all over 5. And again, 5 can't divide into 10. 5's done. 3/5 root 10. Rationalizing the denominator for problems like this is you're going to multiply this by the conjugate, okay? And what that means is this middle term here is going to become the opposite. And so you're going to multiply it by whatever this term is, but its conjugate, which is the opposite sign in the middle. Be careful that you do not multiply, you don't change the sign if there's a negative sign out front. This is actually, I've seen this on a similar question on the SAT, where this is sort of a trick question. You're not changing that negative sign in front of the 3, okay? So again, you would just multiply by 3 plus 2 root 5 over 3 plus 2 root 5, which is its conjugate. And the whole objective here is to lose the denominator. And so you're going to distribute. So 6 times 3, we have 18. And then 6 times 2 root 5 is going to be add 12 root 5 all over. And then this I'm going to multiply, again, FOIL. But the objective here is to get rid of the root on the denominator. So hopefully we're going to do that. 3 times 3 is 9. 3 times 2 root 5 is 3 times 2, 6 root 5. And this is going to become negative 6 root 5. So those cancel. You want that to happen. And then the last ones are these two. So that's going to be minus 4. And then root 5 times root 5 is 5. So 4 times 5. So I have actually 9 minus 20. which is negative 11. And so my answer, this would be my answer right here. I definitely can split this up. So like if you're taking one of those big tests, right, and you don't see this being an answer, you might see something like this. So negative 18 over 11 minus 12 over 11 root 5. See how I split the denominator up? That's the same answer, but it's just written a different way. For these problems here, just more practice, and if you know this, then move ahead. 2 root 32, so that's going to be 2. Think perfect square. So I'm thinking 16. So 2 times root 16 times root 2, plus 3 times root 8, which is root 4 times root 2, and then minus 4 root 18. So 4 times root 9 times root 2. Okay, so just simplifying these as best you can. Root 16 is 4, so I have 2 times 4, which is 8, root 2, plus, and then root 4 is 2, 3 times 2 is 6, 6, root 2, root 9 is 3, so I've got negative 4 times 3, so minus 12, root 2. Because these are all root 2's, I'm going to have just one term as my answer. So 8 plus 6 is 14, and then 14 minus 12 is 2, so I've got 2 root 2, and so that's my final answer. For this one here, again, your objective is to get rid of the roots, or not, actually, they're not on the denominator, so we just have to FOIL. So again, remember, numbers get multiplied with numbers, so 4 times 1 is 4. So we have 4, root 3 times root 3 is 3, so 4 times 3. And then this times this is going to be negative 5 times 4, which is 20, and then that's going to be root 6, because the roots get multiplied. 1 root 2 times 1 root 3 is root 6. So this is going to be positive root 6. And then root 2 times negative 5 root 2. So negative 1 times negative 5 is negative 5. And then root 2 times root 2, which is 2. So I have 12. And then negative 20 plus 6, or plus 1 right here, is negative 20 plus 1 is negative 19 root 6, and then minus 10. So 12 minus 10 is 2. So my answer is 2 minus 19 root 6. For this problem here, adding and subtracting. So these are your objective for these problems is to get a common denominator and then add them together. And once you have that value on the denominator that's the same, all you have to do is add the tops, the numerators. So for example, if I have x over 5 plus 3 over 5, because my denominators are the same, right, I'm just going to have the same denominator, 5, and then I'm going to add the numerators, which is x plus 3. These are expressions. You don't see any equal signs. Don't add equal signs if you don't see an equal sign. Okay, so for this problem here, I noticed that my common denominator is going to be a combination of, or the product of, 5 times x. So this needs a 5 times a 5. This needs an x times over an x, or 5 over 5 and x over x. And the rationale here is that because it's an expression, you can multiply by 1 in any form. So in this form, I'm multiplying by 5 over 5, which is 1. In this form, I'm multiplying by x over x, which is 1. So what that means is I'm not changing the actual expression, which is good. So what I have now is on the denominator is 5x. And then on the numerator, I have 20 plus 3x. And that you're done. You're just finished. Don't add, don't do anything, because you can't cancel this 5 with the 20, because this 20, you have to be multiplying on the top. This numerator is actually a term. And the only way that I could cancel this 5 with something on the top is if there was a value out front, like a 10. Then I could cancel that 5 with that value out front. And because there's nothing that I can factor out, there's nothing that I can reduce. And definitely don't reduce those x's. Do not do that. All right, for this problem on the bottom, on the left, what we're going to do is we need to get a common denominator. And I noticed that there's no common denominator. This is a term. This is a term. Do not split this up and multiply this by 1 or this by 2. That's not how it works. It's a quantity. And so what this side, this left side is missing is it's missing the quantity x minus 1. So I'm going to multiply this left side by the quantity x minus 1. over 1, which of course is 1. And on this side here, I'm going to multiply by x plus 2 over x plus 2. Again, 1. And therefore, I'm going to have common denominators, which, because I have a common denominator, they're going to have, just like this right here. See how the denominators are the same? You have a common denominator then. And so my common denominator is going to be x minus 1 times x plus 2. And then on the numerator, I'm just going to distribute and then add those values together. So 5 times x, so I get 5x minus 5 plus, and then 2x plus 4. So 2x, add 4. So now I'm going to combine like terms, and I get 7x, 5 and 2, minus 1, over x plus 1, x minus 1 times x plus 2. And absolutely, you can multiply these out, and that's fine. For these, again, for these two problems here, this right side is going to need an x minus 2, and this left side is going to need an x plus 1. So here, I'm going to multiply by x minus 2 over x minus 2. Here, I'm going to multiply by x plus 1 over x plus 1. Now, when I multiply these through, I'm going to have this common denominator plus this common denominator is going to be x plus 1 times x minus 2. Now, on the numerator, I'm going to distribute again. So I'm going to get 2x plus 2. And then be very careful, because this is a negative sign. And so that negative sign goes with the 3 when you multiply. Okay, that goes with the 3. So it's negative 3 times x, which is negative 3x. And it's negative 3 times negative 2, which is positive 6. So 2 minus 3 is negative x. And then 2 plus 6 is 8. So plus 8. And that, and then I get x plus 1 times x minus 2. And again, yes, you can absolutely multiply those out if you want to put that in a more simplified form. But please remember, never, ever, ever cancel those single terms like that. You can't cancel that x with anything. You're going to have x squared minus 2 plus 1. So that's negative x, and then minus 2. This would be my solution. Again, do not cancel those negative x's. Don't cancel those. Don't cancel the 2. You can only cancel quantities over quantities that are multiplied, okay? For this one, add or subtract, again, we're trying to get a common denominator. Common denominator oftentimes is just the product of the two put together, okay? And so this one is going to be needing a 2x add 3 over a 2x plus 3. And this one needs a 5x plus 4 over a 5x plus 4. Again, it's a quantity divided by itself. And so when you get something like that, that's just 1. And I'm not changing the problem if I'm multiplying by 1. I'm just manipulating it, right? All right, so what we have here is distribute. We got a common denominator. My common denominator, I'm going to keep it in quantities. So I've got 2x plus 3 times the quantity 5x plus 4. And then on the numerator, I'm going to distribute. So I'm going to get 4x plus 2x times, 4x squared plus 2x times 3, which is 6x, plus 6x times 5x is going to be 30x squared. And then 6x times 4 is plus 24x. So I need to simplify this if at all possible. So it looks like I've got 34. I'm going to go to the top here. So I've got 34x squared, and then 24 plus 6 is 32x at 30x. Sorry about that. And then over these 2x plus 3, and then 5x plus 4. Now, I'm wondering if I can factor something out here. So I'm looking at these two values here, and I know for sure I can factor out an x. What can I factor out of 34? Maybe a 2, right? As that's 2 times 17. So I get 2x times 17x plus 15. That really actually didn't do anything for me. So I would just leave my answer like this, because this 2x definitely is not canceling with anything on the denominator unless there was a number outside, right? If there was a number outside the parentheses that I was multiplying, then I would definitely be able to, cancel that. For this problem here, Before I multiply by the whole quantity, I'm going to see if I can factor anything out of this. So in factoring something out of this denominator on the right, probably it looks like a 4. If I took out a 4, factored out a 4, I would get 5x plus 4. And for this left, so trying to get a common denominator, I'm going to have to do a little manipulating, definitely. Because on the left, this number needs to be a 4. So I need to multiply by a 2. And then, so I need to multiply by a 2. But also, I need to also multiply by the 5x plus 4. 5x plus 4. On the right, it looks like that's a 2. So 2 times 2 is 4. But I have a 4x. So this is going to be 4x times 5x plus 4. And on the right-hand side, it does look like I'm missing an x. So this one on the right needs to be multiplied by x over x. The one on the left is going to be multiplied by 2 times 5x plus 4 over 2 times 5x plus 4. And now I'm going to have a common denominator. So my common denominator, again, is going to be 4x times 5x plus 4. And then on the numerator, 7x times 2 is 14x times 5x plus 4 minus, and then I've got this x over x. So I'm just going to put this x here for a minute, x times x minus 2. So I do need to simplify the numerator. So 14 times 5 is 70, so that's going to be 70x squared plus 14 times, what is that, 56? 14 times 2 is 28 times 2 is 56. So looks like 56x minus x squared and then plus 2. So adding all that together, I get what? 69x squared plus 56x, add 2. And then that's all over this term here, right? Which I'm just going to multiply out since I already multiplied the numerator. 20x squared plus 16x. So this would be my answer. It's a little messy, but you know, that would be it. And I would definitely try to factor, of course, the numerator. But in this case, I don't believe it factors. There's a little Nearpod, little 4-question thing that I want you to do. And we'll do that in class. I think like a good break. Who's rational, right? Thor is awesome. These are called complex fractions. And we've done these before. And we're just doing a little bit of slight review on this where we're going to divide. And so this line here means divide. So what that is 6 divided by this quantity here. Now, before I divide by this quantity, I actually, and again, you don't see an equal sign, so don't add one. This is just like arrow to the right. This is, this needs a 9 over a 9 and to get these together. And this needs a u over a u. And so this is going to then be on the denominator. I'm just simplifying the bottom right now. 9 times 4, which is 36 over 9u, and then 36 minus 4u. Okay? And so this, and that's 6 divided by, see there's the divided by, 36 minus 4u all over 9u. So now this is 6 divided by the reciprocal of that. Right? So that's divided by 36 minus 4u over 9u. I could definitely go right to the next step. If you wanted to skip this step, you could. And then you would get 6 times the reciprocal, which is 9u, this is a u, over 36 minus 4u. And so I'm actually going to factor out a 4 because I know 9 times 4 is 36. So I'm going to factor out a 4 and get 4 times 9 minus 2u. The reason being is that because when I multiply these out, of course, I'm going to try to factor a little bit and see how I'm multiplying. I can factor out a 2, and then that makes that into a 3. So my final answer for this problem would be 27u over 2 times 9 minus 2u. And yes, you can leave it like this. You also could simplify this slightly to 27u over 18 minus 4u. That would be fine. Do not cancel the u's. Do not cancel any numbers. You're not multiplying. Do not cancel. For this problem, this one is right to the point. You don't have to combine any terms before you divide. This is just 3 over x minus 4 divided by 9 over y squared. So this is one of those steps that is not actually necessary. This one, because most of you in, this class should be able to realize that a division is the multiplying the reciprocal. So realistically, we have 3 over x minus 4 times y squared over 9. And so then the 3 will cancel with this 9 3 times. And because I'm multiplying, I can cancel. These don't cancel, so I actually have y squared over 3 times the quantity x minus 4, and then I'm done. And you just leave it like that. Subtract and simplify. This is just a little bit trickier problem in that we are trying to get a common denominator, but before I can subtract, I need a common denominator, and I need a factor to see what my denominator is before I can get a common denominator. All right, because obviously they're not the same. This is going to be x times x. This will be x times x. To get 3, a negative 3, this is going to be a negative 3 and a positive 1. This one, to get a 2 and a negative 1, would be a negative 2 and a positive 1. And so what I'm seeing here, and let me see if I could move these over. Oh, that's not going to work. What I'm seeing here, sorry, is that I have an x minus 1 that's common. Because ultimately, I'm trying to get a common denominator so I can add the numerators. That's what you're trying to do. Combine these two into one term. And in order to combine them into one term, you need a common denominator. So x plus 1 is going to be one of my denominators. Check. They both have x plus 1. Done. Right? The next one, though, is this side needs a x minus 2. So I'm going to multiply this by x minus 2 over x minus 2. Again, that's 1. I'm not changing the problem. This one needs an x minus 3. So this needs to be multiplied by x minus 3 over x minus 3. And so now I have a common denominator. It's x plus 1 times x minus 2 times x minus 3. And multiplication is commutative, right? And 5 times 6 equals 6 times 5. You can flip those around, get the same number. Leave that like that. Doesn't matter for the order. But for this, I do need to FOIL and I need to distribute. So x times 7x is going to be 7x squared. X times negative 1 is negative x. Negative 2 times 7 is going to be negative 14x. And negative 2 times negative 1 is positive 2. And then see this negative sign? Again, that goes with the negative 6 when you distribute. So negative 6x times x is negative 6x squared. Negative 6x times negative 3 is positive 18x. So now what we're going to do is I'm going to try to get I'm going to try to get a common, I'm going to simplify the numerator first. And in simplifying the numerator, I'm going to get 7x squared times 6x squared, or minus 6x squared, is 1x squared. So I have x squared. And negative x minus 14x is negative 15x. Negative 15x. Plus 18x. So plus 18x is 3x. So that's going to be plus 3x. And then I have a positive 2. And this, again, is x plus 1 times x minus 2 times x minus 3. So on the numerator, I am going to factor that. It does look like it's going to factor to be x plus 2 and then x plus 1 all over x plus 1 times x minus 2 times x minus 3. And so it does look like the x plus 1s, because I am multiplying as a quantity, they are going to cancel. No equal signs. This is an arrow. My final answer is going to be x plus 2 over x minus 2 times x plus 3. And these aren't the same. These aren't the same. So do not cancel those. They have to be exactly the same for you to be able to cancel. Okay? Last one of these, trying to get a common denominator. I specifically picked this x minus 2 and 2 minus x because remember, these are the opposites. Meaning if I rewrote this, I get negative x plus 2, right? And if I factored out a negative sign, I now have negative times the quantity x minus 2, which is this right here. So far, right, this is gone. I've factored that. I've simplified it. Now, what I have is 3 over x minus 2 plus 4 over negative x minus 2, which basically means, hey, these are the same values, right? It's just now just x minus 2, and that's a minus sign. Okay, so I'm just going to leave one minus sign for right now. And then on the denominator, this is over 1 over x, which these don't have. This has got an x minus 2, an x minus 2, but an x. So what this side needs is an x minus 2. That needs an x minus 2 over an x minus 2, which these already have. But these two on the left both need an x. So I'm going to multiply this by x over x and this by x over x. Okay? And so what I get on my denominator is x times x minus 2. And the numerator, this is where the negative sign is going to come back, okay? So I've got 3x, right? And then, see the minus sign? That's minus 4x, so minus 4x. And then distribute, plus x, and then minus 2. So combining like terms, I get 3x minus 4x is negative 1x. And negative 1x plus x is 0 x's, so these are all gone. And then I just have negative 2 over x times the quantity x minus 2. Done. Now, there is actually a way to check your answer, and that is to go back to the original question, right? The very, very beginning, at the beginning. Plug in a number like 2, 1, 0, right? Oh, can't plug in 0 because that would make this denominator undefined, right? So can't pick 0, can't pick 2 because 2 minus 2 is 0. That 2 is a bad choice. But pick a number, 3. And so realistically, I would get 3 minus 2 is 1. So 3 over 1 plus 4 over 2 minus 3, which is negative 1. So this is 3 minus 4, which is negative 1. And then plus 1/3, right? That value, that if you just picked any number and then you plugged it in here, negative 2 over 3 times 3 minus 2, I'm going to get the same answer, okay? Because you should get the same value. You just are rewriting it. That's all you're doing is combining like terms. But you don't have to, I mean, you could pick 5, you could pick 10. Pick anything that's not going to make the denominator an extraneous solution, which is our new word for this chapter for not today, but another day. Okay, so this is a really great, I love this example. Okay, so moving forward, partial fractions, right? Who's not ready for Venom 2? Coming up, right? Awesome. Okay, partial fractions, you get it? Okay, anyway. All right, partial fractions. What are partial fractions? It's like a game of Jeopardy, right? Where you have the answer and you got to come up with the question. So what a partial fraction is how to find the actual parts to the question that they asked. So they're going to give you this. No, that's not what they're going to do. They're going to give you this value right here. See the 5x minus 4 over that? If you were to combine these two terms, you're going to get 5x minus 4 over x squared minus x minus 2. But what if they gave you this as an answer? And they said, hey, here's my answer. What was the question? How am I going to get back to that question? Now, partial fractions are super cool because this is like one of the only ways, you know how you say, hey, this is an expression. There's no equal sign. This is one of the only instances where you actually add an equal sign. All right. And most importantly, you're going to work backwards. So realistically, why are partial fractions important? Because you're going to use these a lot in integral calculus, which is, a year or two down the road for some of you or next year for some others. But again, we have to be able to come up with the question given a solution. So there is a way to do that. I've listed this for you. They call it partial fraction decomposition. I am going to go over this with you because I want you to be able to know exactly what they did. So does it say, nope, not that one. I'm going to start with this one right here, 5x minus 4. So I'm going to add a slide here because I do want to do this one. So two things are going to happen. Number one, I'm going to add a slide. And number 2, add one of these, put this here. And so we're going to try to come up with the question. All right. So this is how you do this. You make this set equal to, right? Add an equal sign. First factor first. So let's factor first. Write that down so you have that note. Factor first. So this is going to become x times x here. So minus 2 and then plus 1. Okay, so see how I have two parts? I have an x minus 2 and I have an x plus 1. Those are my two parts. So basically what that means is that they added, somebody working backwards to add the question. They went, well, one of my denominators is x minus 2 and the other denominator is x plus 1. And I'm not sure what that value is, so I'm just going to call that A, and I'm going to call that B, because we don't know the numerators yet, okay? So factor first, number 1, we did that. Number 2, combine the two terms. Combine the two terms. All right, so I'm going to combine the two terms, and I'm going to notice, oh, hey, I need a common denominator to add those together. So this side here needs an x plus 1 over an x plus 1. This side needs an x minus 2 over an x minus 2. All right, and so what that means is, hey, now I have a common denominator. And so I'm going to get x plus 1 times x minus 2 as my denominator, but my numerator, I do have to distribute. So I'm going to get ax plus a plus bx minus 2b. Okay, so there's my numerator after I combining those two terms, my two fractions. And remember, this equals the equal sign that we added, right? And that equals x squared minus x minus 2. Now, what you need to realize is that if I were to cross multiply a common denominator, see how these denominators are the same? They are going to actually cancel out. So let me show you on a simpler term. If I had 5 over x, 2x is equal to, let's say, 3a over 2x, right? What happens when I cross multiply? I'm going to get 5 times 2x equals 3a times 2x. Now, I'm going to divide both sides by 2x, obviously. And when I do that, my 2x's, which are my denominators, are actually going to cancel out. I'm going to get 5 equals to 3a. Do you see that? And solve for a. So the same concept is happening here, where we are trying to get we have a common denominator, and this value equals this. These equal, this equals that. So that means that if I were to cross multiply, they would cancel. The denominators would cancel, and that would leave me with my numerators to set equal to each other. So now I have my 5x minus 4 equals ax plus a plus bx minus 2b, all right? So step 3 is basically cross multiply and get rid of the denominator. All right, now this is where it gets a little bit tricky. You are going to combine like terms, meaning this 5x is going to equal ax and bx. See how they're all like? So I'm going to set that like that. I'm going to go 5x is equal to ax plus bx. And then I'm going to say to myself, you know, I believe I can reduce this a little bit and get rid of the x's, right? If I divide everything by x, those are gone, aren't they? So now I just have 5 equals a plus b, or I'm going to say a plus b is equal to 5. Secondly, I've got my negative 4. Okay, so for my negative 4, I have a negative 4, I have an a, and I have a negative 2b, which means that a minus 2b is equal to negative 4. Okay. Oh my goodness, it's a 2 by 2. We know how to do this. So one way to do this, I mean, like, there's so many ways to solve a 2 by 2, right? One way to solve a 2 by 2 is just add or subtract. You've got elimination, you've got substitution, you've got all this stuff, right, that you have. But if it's a plus 2b, so you have a plus b, I'm just going to actually, what do I want to do? I'm going to subtract, because that seems like it's the quickest, easiest way to solve this. So I'm just going to subtract the top minus the denominator, or the bottom equation. So a minus a is gone. b minus negative 2b makes 3b. And then 5 minus negative 4 adds to be 9. So 3b equals 9. So b is equal to 3. So now I've got b. Go back to one of your equations. I'm going to pick this one. And I'm going to plug in 3 for b. So I get a plus 3 equals 5. So a is equal to 2. We're done. Go back to the original question. What was the question? Here's the answer. What was the question here? Now, the only trick here is that you need to make sure that your a value is on top of the x minus, whatever you put it on. See how we put b over the x minus or x plus 1 and we put a over the x minus 2? This is going to be realistically different for everyone if they flip-flop the denominators. So a, which is my 2, is over the x minus 2. So this is what you would write for your answer. So 5x minus 4 over x squared minus x minus 2 equals your a, which is 2, over x minus 2, and then plus b, which is 3, over x plus 1. And so 2 plus, that's what I get. And so if I went back to the actual previous screen where I also listed the steps here, you're going to get 2 over x minus 2 plus 3 over x plus 1. Notice that, we've got the same answer. Sometimes they're going to be in a different order. Totally fine. So we're going to try to do this one as expressed as a partial fraction. And I want you to pause the video, you try it, and then turn it back on and check your answer. Okay. So I'm assuming that you did that. You came back. Hey, welcome back. They've already factored this for me, so I don't have to factor anything. So all I have to do is set up add my equal sign. Right. I know. Never add equal unless it's a partial fraction. A over x plus 4 plus b over x minus 2. Okay, again, you want to combine those. As soon as you factor, check, you want to combine the two terms with the common denominator. The common denominator is going to be x plus 4 times x minus 2. And so this value needs an x minus 2. So we're going to multiply by x minus 2 over x minus 2. This one needs an x plus 4 over an x plus 4, which is, again, 1. I'm not changing the problem. And now I'm just going to distribute. I get ax minus 2a plus bx plus 4b. And so this equals my 8x plus 14 over x plus 4 times x minus 2. And I know that when I cross multiply, my denominators are going to cancel. So now I can set my numerators equal to each other while combining like terms. So I've got my 8x is going to combine with my ax and my positive bx. And at the same time, I'm going to divide by x. And so I'm going to get a plus b is equal to 8. This is the 8, okay? Over, see the 14 by itself? That's my 14 here. And then this is going to be negative 2a plus 4b. So negative 2a plus 4b. Okay. Now, just a note, this is a plus b equals 8. I've got negative 2a plus 4b equals 14. So I would remember how I told you all the different ways we know how to do this. We would definitely multiply by 2. We could do elimination. We could do augmented matrices. Nobody likes that. Also, calculator. So I do have a calculator handy here, and I want to show you. Remember, bring it back to our matrices. This is a 2 by 2. So I'm going to click on that. I'm going to put my values in. A plus b is just a 1 and a 1. And the bottom is a negative 2. And this is a 4. To the right, remember, it's going to be to the negative 1 power. And then we also now have a 2 by 1. So let me go back to matrices. There we go. 2 by 1. These are my determinants. And I've got 8 over 14. Now, the TI-84 remember, does this differently, but this is how the Inspire does it. It's the inverse of that value. And all you have to do is hit enter, and you have 3, 5. Now, 3 is my A, 5 is my B. So I go back here, and by calculator, I know that A is equal to 3 and B is equal to 5. So therefore, my answer, when I put it back into my equation, is going to be 3 over x plus 4 plus B, so I'm right here, B, which is 5, 5 over x minus 2. And so there's my answer, expressed as a partial fraction. Right on. One more, and then that's it. So what we have here is, I think one more. Factor first. So we have 12x minus 1 over factor first. I would, you do this, come back after you're done, check your answers, okay? This is x, this is x. To get a positive x, it's going to be plus 4, it's going to be minus 3. And again, a over x plus 4 plus b over x minus 3, okay? Get a common denominator, which is going to be x plus 4 times the quantity x minus 3. So this side needs an x minus 3 over x minus 3. This side needs an x plus 4 over an x plus 4. Denominators are going to cancel, and now I'm left with setting the numerators equal to each other. So I'm going to do a little simplifying. I get 12x minus 1 equals ax minus 3a plus, be careful on the sign, right? Just that goes with the b. So that would be plus bx plus 4b. And then combine your terms, right? I've got combine my x's, and so I'm going to go, oh, that's a plus b equals 12. And then I've got the negative 1 is here, and that's going to be what's left, which is my negative 3a plus 4b. So negative 3a plus 4b. Now, these are a 2 by 2. Would you ever get a 3 by 3? It is completely possible. And then, of course, I would totally use my calculator. This would, again, using your calculator when you're doing these problems is just such a great idea, I think, in my opinion. If you want to, and if not, you just do this by hand, right? You would multiply the numerator by 3, get rid of your a values, but I'm just going to remind you how to solve a matrix C on the TI 84 since I just did the TI Inspire. So the way, again, you do it is you go to matrix. So you're going to go second matrix, right? You go over to math, edit, and hit enter. There's your A matrix, right? And 1 second, I forgot what's the question? Let me write this down real quick. A plus B equals 12, and I have negative 3A plus 4B equals negative 1. Okay, so when I'm doing this, right, this is a 2 by 2. So I'm going to enter 2, enter 2, enter. So now there's my 2 by 2. And I've got 1, enter, 1, enter. And on the denominator, I have a negative 3. So negative 3, enter. And then it looks like I have a positive 4, 4, enter. So when you're done, after you've entered this, you need to quit. So second quit, all right? Go back to matrices, go back to matrix, and go over to edit to the right, and then go down to the number 2. Now this matrix is going to be a 2 by 1. So 2, column, right? Row by column. So 2 rows, 1 column, enter. And then those numbers are 12. So I've got a 12, enter, and a negative 1. So a negative 1, and then enter. Now this is where, and then you have to quit. So quit. So this is where it's very similar now to the TI Inspire, because this is where the inverse comes in, right? So you're going to go second matrix, go back, and I'm going to hit enter. So there's my A term. And I'm going to make that go to the negative 1 power inverse, just like we did with the matrix, right? 2 by 2. Whereas here we have to assign a matrix to it, whereas the TI Inspire, you just type directly into the matrix, right? And then again, second matrix, because I've got to get my B term, which is down here. So go down and hit enter. and then enter one more time. And so my A is 7 and my B is 5. And so that means that A is 7. So we've got A is equal to 7, B is equal to 5. And I know that took time, of course. But as you go through this and you start getting problems that are a little bit trickier, I mean, it's your choice. Do it by hand or do it by calculator. You have access to your calculator. You can do that on any of the problems, okay? All right. So I just have to rewrite it and put A over x plus 4. So 7 over x plus 4 plus B is 5, over x minus 3. And that's my question, right? Given the answer, which is this value, what was the question? And for those of you doubters, absolutely do this on your own and then see what you get. You should get the 12x minus 1 over that. Also, super fun. Yes, I know sometime when you end up taking the SAT again, this is on it. I know, you need to know this. One more, and then we're done. We've got, again, 7x minus 23, and we've got x, this is to get a negative 7, so it's going to be a negative 4, and x minus 3. This equals my A over x minus 4 plus my B over x minus 3. I'm going to get a common denominator here. So my common denominator is going to be a combination of x minus 4 times x minus 3. So x minus 3. This will be an x minus 4. And this will be an x minus 4. Denominators are going to cancel. Set the numerators equal to each other. And so I get ax minus 3a plus bx minus 4b. Okay, and again, group your terms. I'm going to group my x's and lose the x at the same time. So I've got a plus b is equal to 7. And then I've got negative 23 is equal to, I've got a negative 3a, and then I got a minus 4b. Okay, so for me, I'm just going to solve this. I'm going to, I'm going to use my calculator. And so a plus b, and pause and do this yourself to make sure that you can do this. I get negative 3a minus 4b is equal to negative 23. I'm going to go back to the TI Inspire and do one like that. And so on this one, I've got my choose your 2 by 2, which is the 4 values. Click twice. You type in your 1. I've got my 1. I've got a negative 3 and a negative 4. And then again, I need to go to the hat and then hit negative 1 to the negative 1 power. That's your inverse, right? In a TI Inspire, you're calculating directly into this. And then remember, I gave all of you guys licenses for the TI Inspire and or the TI 84. So you guys have that for 3 months, which is, I think, super cool. Thanks to TI. Okay, go back here. You click on this. And I think, what were the two terms? 7 and then negative 25. So I hope I copied those right. Negative 25. Enter. 3, 4. A is 3. B is 4. So we're all done. We get A is equal to 3. We have B equals 4. You don't write your answer like this, by the way. You have to rewrite it as a partial fraction. See, express as a partial fraction. So this was going to equal A, which is 3. So this is going to be 3 over x minus 4 plus B is 4 over x minus 3. And so this is my solution. That's my partial fraction. So we did everything we set out to do. Nice job. You guys have homework. There it is. Good luck. And see me in office hours if you have any questions. Right on. Have a great day.